Hello, let's start chapter 5. Chapter 5 is all about integration, and section 5.1 is all about the indefinite integral. Okay? When we say integration, what do we mean? Okay? Integration is the opposite of taking the derivative. So we call it integration is anti-differentiation. Okay? The anti-derivative, the anti-differentiation. So let's start off by information. If f of x is g prime of x, then the integral, so this is the integral sign, it's an elongated s, of f of x dx equals g of x, g of x plus c. Okay. So this is how we write the integral. So this is saying the integral of f of x dx. You always have to have that dx there. It tells you what your variable is. Let's do an example, and then hopefully you'll be able to see exactly what this is saying. So I want to find the integral of 2x dx. Okay? So now I have to think to myself, what do I take the derivative of to get 2x? So for which function is the derivative equal to 2x? So you think to yourself, okay, well, I know x squared, if I take the derivative of x squared, that gives me 2x, right? But x squared plus 3 also gives me 2x, x squared plus 10 also gives me 2x, the derivative of x squared plus pi also gives me 2x, so any constant c. So here we call c a constant, okay? Why is this? Because, this is b slash c, because the derivative of x squared plus c is 2x. Okay? So just like we have a power rule for derivatives, we have a power rule for integration. And the power rule says the following. If I want to take the integral of some variable to the nth power, d of x, okay, that's 1 over n plus 1, x to the n plus 1. Oh Lord, let me write this better. That's n plus 1. Oh dear, something's up with my pen. Let me see. N plus 1, okay, plus c. Okay. Where n cannot equal negative 1. Okay. This is the power rule. What does the power rule tell us? Remember before we would subtract 1 from the exponent when we took derivatives? Now what you want to do is you want to add 1 to the exponent and then divide by the new exponent. Let's do some examples. Let's take the integral of x squared, just like we saw. We didn't see this one earlier, but what am I going to do? I'm going to add 1 to the exponent and divide by the new exponent. So the new exponent is 3. So that gives me x to the third over 3 and then plus c, okay, which you can also write as 1/3 x to the third plus c. So either of these is fine. You can write it as 1/3 x to the third or x to the third over 3. Okay, let's look at the square root, or the integral of the square root of x dx. Okay. Now notice, when I take the integral, I don't write the integral sign. Right? Let me rewrite this. So I haven't taken the integral yet, I'm just rewriting it as x to the 1/2. Okay. Again, you add 1 to the exponent. So adding 1 to 1/2 gives me 3/2. And dividing by 3/2, which gives me 2/3. We don't like to see those complex fractions, so we write it like this. Okay. Again, we added 1 to the exponent. 1 plus 1/2 gives me 3/2, and you divide by 3/2, which is the same thing as multiplying by the reciprocal 2/3. Let's look at number 3. The integral of dx over x cubed. Okay. So let's rewrite this. Now I haven't taken the integral yet, I'm just rewriting it. That's the integral of 1 over x cubed dx. Okay, so when you multiply dx times 1, you get dx on top. And then again, let me rewrite this. This is x to the -3. Okay. Now I add 1 to the exponent. So adding 1 to the exponent gives me x to the -2. And then you divide by -2, which is multiplying by -1/2. Okay? And that is plus c. And then since our original function does not have a negative exponent, our answer should also follow the same format and not have a negative exponent. So we can write this as -1 over 2, and that x squared is on the bottom. Okay. Let's look at another example. The integral of 1 dx. Well, what's another way to write 1? Isn't it just x to the 0? Okay, so again, you add 1 to the exponent, so that, and divide by the new exponent, which is 1 plus c. So this just gives me x plus c. So the integral of 1 is just x plus c. Okay. What if I had the integral of 6? Well, that's like the integral of 6 times 1, isn't it? Well, we can pull that 6 outside and do this, the integral of 1, which we know is x. Technically, it should be like this, right? But 6 times c is still going to give me a constant c. Okay? So this is the constant multiple rule. Oh, and I should mention that there are no guided notes for this chapter. You just have to take the notes on your own papers. Hopefully you are doing that. The constant multiple rule says the integral of k times some function f of x dx. Okay, you can just pull that k to the outside. That's k integral, like we did above. Okay, this is the constant multiple rule. Just like we have constant, you leave the constant multiple alone for derivatives, you also leave the constant multiple alone for integrals. Okay, let's do another example. So the integral of 4x squared dx. Okay, so what I'm going to do is just leave that 4 alone. Okay, don't bother with it, just leave it. And add 1 to the exponent, divide by the new exponent. So then my answer becomes 4/3 x to the 3rd plus c. You can pull that 4 out and then multiply it back in, okay, which is the same thing as just leaving it alone. Okay, so the derivative of a constant is 0, but once you're multiplying by a constant, you leave it alone. Same thing with integration. you have a constant, just leave it alone. Okay. Let's do another example. So now I have 6x squared minus 3x to the negative 2 plus 5. Oops. Dx. So the dx tells you the take the integral with respect to x. Alright, so each of these we're going to do in pieces. So let's look at the 6x squared first. So I'm going to add 1, divide by the new exponent. Okay. Again, add 1, negative 2 plus 1 is negative 1, and then here put an x. Okay. So that gives me what? 6 x to the third. So 6 over 3 is 2 x to the third plus negative 3 over negative 1 gives me positive 3 x to the negative 1 plus 5x, and then don't forget the plus c. Okay. And then let me just clean this up a little bit more. We can write this as 3 over x. So this is the fully simplified answer. Alright, let me scroll down a little bit. Oops. Alright, let's look at another example. Let me scroll to the next page. If I take the integral 3 root x over 2. So when you're adding and subtracting integrals, you just take the integral and then add or subtract. Okay? So just like with derivatives. Dx. Okay. So what does this give me? Let me rewrite this to make the integration easier. So it's 3/2 x to the 1/2 minus 2 x to the negative 1/2 dx. Now what is the integral of that? So same thing I did before. I'm going to add 1 to the exponent. So 1/2 plus 1 gives me 3/2 divided by a 3/2. Okay. So I have, let me erase this here. Oh Lord. Minus, okay. So 3/2 x to the 1/2 plus 1 is 3/2. And then I have to divide by 3/2, which is multiplying by 2/3. Okay. And then negative 1/2 plus 1 gives me positive 1/2. So I have 2 divided by positive 1/2. Or you multiply by 2. And then don't forget the plus c. So let's clean this up a little bit. 2/3 and 3/2 are gone. So we get x to the 3/2 minus 2 divided by a half, which is 2. The reciprocal of 1/2 is 2, so 2 times 2 gives me 4. X to the 1/2 plus c. Okay. And then let me rewrite this in radical notation, since my original function is in radical notation. This is square root of x to the third. Now the third could be on the inside or outside, it doesn't matter. Minus 4 root x plus c. Okay. So again, what did we do? We added 1 to the exponent and divided by the new exponent. Okay, when you're dividing fractions, it's the same thing as multiplying by the reciprocal. Right, let's look at another example. X squared times x plus 6 squared dx. So So here we have a product. So remember when we took derivatives, we had the product rule for derivatives? Well, we don't have anything like that for integrals. So the only way to deal with this problem is to FOIL it out and distribute. So x plus 6 squared gives me x squared plus 12x plus 36. And then I have to multiply everything by x squared. Now notice how I'm rewriting the integral sign because I have not taken the integral yet. I'm just simplifying. So that gives me x to the 4th plus 12x to the 3rd plus 36x squared dx. Okay. Now I can take the integral. So that's add 1 to the exponent. So that's x to the 5th. Divide by the new exponent. So that's multiplying by 1/5. Plus add 1 to the exponent, which is x to the 4th. And then 12 divided by 4 gives me 3. Add 1 to the exponent. That's x to the 3rd. Divide by the new exponent. If I divide 36 by 3, I get 12. And then don't forget the plus c. Okay. So that's my answer. Let's look at an example in the book. So this is on page 330 in your class textbook. Okay. So this example right here. A company's marginal cost function is given by this function 6 root x, and the fixed cost is $1,000. Find the cost function. Okay, so let's write this down. So we have the marginal cost is 6 root x, and the fixed cost is $1,000. And they said they wanted us to find the cost function. Okay. So, let's think about this for a minute. So if I give you the cost function and I want you to find the marginal cost function, remember how we did this? We took the integral, or we took the derivative. Okay, so you would do d over dx, or dy over dx, okay, to take the, but if I give you the marginal cost function and I want you to go the other way, then you have to take the integral, okay, because the derivative, the integral is the opposite of the derivative. So let's do that. So to find the cost function, that's capital C of x, that's the integral of the marginal cost function, dx. So that is the integral of 6 root x dx. Let me rewrite this as 6x to the 1/2 dx. And then let me take the derivative. So you add 1 to the exponent. So that's 1/2 plus 1 gives me 3/2. And then you divide by the new exponent, which is multiplying by the reciprocal 2/3. So then, and then don't forget the plus c. So that gives me 6 over 3 is 2 times 2 is 4, x to the 3/2 plus c. Okay. Now we have to solve for that c. That's where the fixed cost comes in. Okay. The fixed cost is the cost when you're not producing anything, right? So when I'm not producing anything, that means x is 0. So for fixed cost, x is 0, y is 1,000. That's what they told me, right? So that means 4 times 0 to the 3/2 plus c equals 1,000. That means c is equal to 1,000. So my cost function, capital C of x, cost function is 4x to the 3/2 plus 1,000. Okay, remember again, that's what fixed cost is. The cost when you're not producing anything. It's like your overhead cost. Okay, and then I can rewrite this as 4 square root of x to the third plus 1,000. Alright, so that is the example in the book. Alright, let's talk a little bit about what integration is. Integration it is just known as continuous summation. That's why we have that elongated S for summation. Okay. Now let me show you a diagram in your book. This is on page 333. Okay, this is on page 333 in your book. If you're looking for, if you want to find the marginal, like if I give you the revenue, the cost, or the profit, and I want you to find the marginal revenue, the marginal cost, or the marginal profit, you would take the derivative, right? If I give you a curve or a function and I want you to find the slope of the tangent line, you would take the derivative. If I give you the distance or displacement and ask you to find the velocity, you would take the derivative. Any quantity that you have and you want to find the rate of change, you have to take the derivative. If you want to go backwards, you have to take the integral. Okay, so remember, integration and derivative and differentiation are opposites of each other. So for example, if I tell you the slope of the line and I want you to give me the function, you have to integrate. Just like the example we did above, I gave you the marginal cost and I wanted you to find the actual cost function, you had to integrate. Okay. So I encourage you to go through and read this section. You should be reading all the sections and going through and doing all the examples in the book. There are some good practice problems here, so go through and do these practice problems. You can do the odd ones, the answers are in the back, and then also the homework. And if you have any questions, get in touch with me. Okay? Thank you for watching.